Hi, this is Carlos Cousins, and we are now going to be solving a quadratic function problem. The first thing that you need to know about quadratic functions, and I hope this is becoming more and more intuitive as you do these problems, is that they are symmetrical. By which I mean, if you look at the classic quadratic function, x squared, y equals x squared, of course, you can see that when you plug in 1 for x, you get x squared for y, which is 1 squared, which is 1 on this side. And when you plug in negative 1 squared is also 1, you get 1 on this side. When you plug in 2, you're going to get 4 on this side. And sorry, I'm going to draw these arrows, because 2 squared is 4. When you plug in negative 2, you also get 4, because negative 2 squared is also 4. Negative times a negative is a positive. So you realize that the y values are the same on either side of the y-axis, and that for every x value, for every absolute value of x. So for this graph, we can go ahead and draw this dotted line to remind ourselves that the image here will be symmetrical on both sides of where this dotted line is. We're also told that the graph of a quadratic function here has a minimum value when f is 2. And I drew it here right through the minimum value, just as the y-axis here goes right through the minimum value of x squared. And we are told that 2 is here. Now, you don't have to draw this if you're trying to solve a problem. You can keep this in your head, but labeling values such as 2 here becomes really important. Something that you should try to do for every graph problem that you see. And again, it's fine if you do this in your head, but labeling on the graph is really important. Is try to think of an XY chart. And the two values that are most important here are when x equals 0 and when y equals 0. What are the other values? So for this graph, we see that when x equals 0, y is some negative value less than negative 1. So we're going to have y is less than negative 1 here. And we see that when y equals 0, x is some negative value. We can't really tell what number it is. So we're just going to write a 1 here, just a negative sign here to signify that. And some positive value greater than 2. If you hadn't labeled that this was 2, you wouldn't know that. Which may not be useful for this problem, but could be useful for another problem. So again, it's really important to be labeling. So x, some x value greater than 2. Okay, and we're trying to figure out when the y value is 0, which of the following could be the value of p. So we know that whatever positive value it is, it must be a value greater than 2. So it cannot be 1. And we see that when y is 0, x is not 0, so it can't be 0 either. But it could be 3 or 4. We don't know. We don't know what this value of x is over here. And then we know that it could also be negative 1, because we also have some negative value, but we don't know which. This is where knowing that the function is symmetrical on both sides comes in handy. So if at 2 it is at its lowest value, we're going to say that at 3 it's going to be some higher value of y that's going to be equal to what it is at 1. And we know that a p-value of 1 doesn't give you a y value of 0. So because the 3 corresponds to the 1, because of the symmetry of this function, 3 can't be an option. And then we can take that further. If we said that this was 4, for example, then we would have to go to the 0 value here, and we know that when p equals 0, y is not equal to 0, so we can cross this value here too. The only remaining possible answer